We're going to go ahead and look at the law of sines today, but first of all, we're going to start off with a way to find the area of a triangle. Now, you guys know that the area of a triangle is 1/2 the base times the height. Well, that works great if you know your base and your height. And your base and height have to be perpendicular. But what happens if you don't know your base and your height? Well, here is another way to find the area of a triangle. It says you need to take 1/2 of your first adjacent side times your other adjacent side times the sine of your angle. Now, when we're talking about adjacent sides, we're talking about the sides that are next to your angle. You'll notice down below here, we have our angle, and we know the two sides on each side of your angle. So we can use that formula by plugging stuff in, going 1/2 your adjacent side times your other adjacent side. The order in which you put in your adjacent sides doesn't make a difference because you can multiply in any order you want, times the sine of your angle. Then you just want to go ahead and multiply across. And then you want to include appropriate units. In this case, since we're dealing with centimeters, it would be a centimeters squared. Now you want to go ahead and do the same thing over here because you have an angle in between two sides. Just go 1/2, put in your two sides, put in the sine of your angle, multiply it out. And in this case, since you are dealing with your units being meters, it would be meters squared. Now let's talk about the law of sines. This one right here, or this one right here, mean the same thing. One is just flipped upside down compared to the other. Whichever one you choose to use is up to you. It doesn't make a difference. Now, I prefer to use whichever one is going to allow me to have what I'm looking for on top. Because if I have what I'm looking for on top, it saves me a step in the process of solving it. So if I'm looking for a side, I'm going to use this first one. If I'm looking for an angle, I'm going to use this second one. Your angles are the capital letters. Your sides are the lowercase letters. And angle A and side A are opposite each other, just like angle B and side B are opposite, and same thing with the C's. Typically, you would only use 2 of the 3 fractions at a time. So you might use the first 2, or you'd use the first and the last, or you would use the last 2, but you're not going to use all 3 at the same time. To use the law of sines, you need to be dealing with an opposite pair. An opposite pair is where you are dealing with a side opposite your angle. So the B's would be considered an opposite pair. If you know both those numbers, then you could work it out. Or if you know both of the A's, that's referred to as an opposite pair, and you could work those out. Or if you know both of the C's, you could then go ahead and work it out. So let's go ahead and talk about the law of sines. Law of sines works great unless you're dealing with a side-side angle situation. And that's what we have here. You'd have this side here you'd be given your adjacent side, and then you'd be given your angle down here. If you're given any of these situations, sometimes it works for you, sometimes it doesn't. So let's go ahead and take a look at what happens. Now, if this side here is just of the right length, it's going to be too short to reach down and form a triangle. And you might be wondering, well, why can I use that? Well, I know this angle, but I don't know this angle up here. So in other words, it's like a hinge up here. So if I can take this and I can swing it back and forth, you'll notice here it's too short to reach down and form a side, or a triangle. But let's consider another situation where this side is a little bit longer. If it's just a little bit longer, it could be long enough just to reach down and form one triangle, in this case, a right triangle. Now, suppose we talk about a third situation. Suppose this side was a little bit longer than that. Now, it's long enough to reach down here and form a triangle. Or, since we have a hinge up here, it could swing down and come over here, and it could form a triangle like this. So you have 2 possible triangles available for the same dimensions. Well, there is a fourth situation, and that's if this side right here is really, really long. If it's really, really long, it forms one really big triangle. If I take this and try to swing it down and over here, you'll notice that it's too long to really form a triangle by swinging it over. So there's only one available, and that's going over here. And that's what happens if you have a side-side angle for um, a acute triangle. But let's take a look at what happens if you have an obtuse angle instead. Obtuse meaning greater than 90. The only way that our angle, or just a side note here, our angle once again is fixed. This side here is fixed. For any given situation, this side here would be fixed, and this side up here is our hinge. Now, in this situation, if we consider this, you'll notice it's really too short to be able to form a triangle. The only way that this will form a triangle is if this side here is longer than your side over here. If this side here is longer than this one here, it's going to be long enough to reach down and form a triangle. So those are the only two possibilities when you're dealing with an obtuse angle. So it boils down to this. If it's an obtuse angle and the opposite side is greater than your adjacent side, then it's one triangle. If that's not the case, then there's no triangle formed. Here we have an acute angle. If the opposite side is equal to your adjacent side times the sine of your angle, forms one triangle. If the opposite side is greater than your adjacent side, it's one triangle. If the opposite side's less than the adjacent times the sine of your angle, then it's no triangle. And that was a situation where the side was too short to reach down. Otherwise, it's two possible triangles. But you only have to consider that if it's a side-side angle situation. If you're not dealing with a side-side angle situation, you don't even need to be concerned about this stuff. So when you're given your problem, you always want to kind of sketch a diagram so you have an idea of what you're dealing with. And you'll notice here we have our diagram. We have a side followed by an angle followed by an angle. So you could write it as an angle, angle, side. It's not what we were looking at on the previous slide, so we know it's just one triangle. Now, we know we can use the law of sines because you see here we have an opposite pair. We know the angle A and side A. And let's go ahead and find all the missing parts. When it says solve a triangle, you want to find all the missing parts. So the first thing I'm going to do is go ahead and try to find side B. Because I know angle B. If I know side B or angle B, I can find side B. So let's take a look here. I'm going to go my side of 10 over the sine of the angle opposite that, sine of 123, equaling the side I'm looking for, B, over the sine of the angle opposite that, which is 41. Now I need to get B by itself, so you're going to undo dividing by the sine of 41. So all I have to do is just multiply both sides by the sine of 41. This is my calculator ready form. I go ahead and type that into my calculator, and I get my decimal approximation. By the way, if you do know two angles, remember you can easily find the third angle because all three angles have to add up to 180. So we can actually find angle C pretty easy by going 180 minus the two angles that we have, which end up being 16. Well, when this angle here is 16 degrees, we still have our opposite pair, so we should be able to use law of sines again to go ahead and find side C. So I'm going to still go my side of 10 over my 123 sine, because that's what I was given, so I want to try to use my given information whenever possible, equals the side I'm looking for, which is C, over the sine of the angle that's opposite of C, which is your 16. Get rid of your dividing by the sine of 16 by multiplying both sides by the sine of 16. Then, that's your calculator ready form. You type it in and you get an answer. So we have our three answers, because we were missing three parts on our problem of our triangle, and so then we have our three answers to satisfy that. So let's go ahead and look at this one here. We have an angle, a side, and a side. If you draw yourself a diagram, here's your angle. You know side A is opposite your angle A. And then we have side B. We know it's just one of the sides that's next to A. Since it's a side angle situation, we got to consider whether it's 1, 0, or no triangles. So we want to go ahead and take a look at the acute angle situation. Is our opposite side here, 5, greater than our adjacent side of 10? The answer is no. Since our opposite side right here is not greater than the adjacent side of 10, we know it's not that situation. Well, when we're looking at either the top situation here or the third situation down, they are both opposite and then adjacent side of your angle. So that's why I have opposite and adjacent side of my angle. The adjacent side is 5, or opposite side is 5, adjacent times the sine of my angle of 25. Now I got to figure out what that is. And in this case now it works out to be about 4 1/4 almost. Now we want to know, is our opposite side smaller than that? Obviously not. 5's not smaller than this. Is it equal to that? They're definitely not equal. So that means we end up having two triangles formed. So let's look at those two possibilities here then. This side right here could come out to the right, or it could swing back to the left and form our triangle over here. So let's go ahead, since we have an opposite pair then, use the idea of the law of sines and find our stuff. So let's go ahead and find angle B here. Since I'm looking for an angle, I'm going to put my angles on top. So I'm going to go, what I know, the sine of the angle I know of 25 over the side equals the sine of the angle I'm looking for over the side opposite that. Go ahead and get rid of the dividing by 10 by multiplying by 10. Get rid of your sine by doing the sine inverse of both sides. This is your calculator ready form. Now we'll go ahead and type it in and we'll get an answer. So now we get an answer for angle B of 57.7 degrees. So now we can easily figure out the missing angle because all the angles add up to 180. So we take 180 minus the two angles that we know, and we get angle C. Now we should be able to go ahead and use the law of sines again. But now I'm looking for side C. So I'm going to put a side on top. So I'm going to go the side I started out with over the sine of the angle I started out with equals the side I'm looking for over the sine of angle C. Now I need to undo the sine of 97.3 by multiplying by that. That's my calculator ready form, and I have my answer. Now let's consider the second triangle that could be formed. We had already shown you how to be able to get angle B. Well, for your second triangle, your angle B is always supplementary to your first angle B. So your new angle B over here is always just supplementary, so subtract it from 180, and that's your new angle B. Well, if you know your new angle B for your new second triangle, and you already know A, you can easily get C because all the angles have to add up to 180. So then we end up getting C to be this. Now, when you know C, you can find side C. And once again, I'm going to go and put side C on top. So therefore, I'm going to start with the side that I knew of 5 over the sine of the angle that's opposite my 5. And then I'm going to put over the sine of angle C, which is at 32.7. Multiply both sides by the 32.7 sine of that. That's my calculator ready form. I type it in and then I now get my decimal approximation.